Hello, we're going to have a go at 93202, the 2025 Scholarship Calculus Examination. I've already put up a video with question 1 on, and I think 4 parts to that question. We're going to look at question 2 today. There are 3 parts, and so let's just scroll down and make a start. There you go, there were 4 parts. Question 2 starts with an equation that has a parametric equation, a function defined parametrically, and it gives us some information about that. Tells us that the y value is p of t, and p of t is given by this cubic. Tells us what the y value is when t is 1. It tells us the derivative with respect to t evaluated at 1 is 6. So, and then it tells us something about the second derivative, what the form of that function is, and we have to evaluate p of 2. In order to evaluate p of 2, we of course will need to know what a, b, c, and d is. So the strategy or the aim in the question is to find a, b, c, and d. That will allow us simply to plug in t equals 2 and find this function. So let's just start. So it says p of 1, which is y of 1, is equal to a times 1 cubed plus b times 1 squared plus c times 1 plus d. That's simply a plus b plus c plus d. And it says that's 2.5. I'm going to write it as 5 over 2. And the derivative, so let's first differentiate with respect to t. We get 3at squared plus 2bt plus c. And if we evaluate that at 1, we get 3a times 1 squared plus 2b times 1 plus c. Oops, don't need a bracket. Do need a c. That's 3a plus 2b plus c, and we're told that's 6. So far we've got 2 equations in 4 unknowns. That's not enough to work out what the unknowns are, but they are going to be useful in order to solve these simultaneously. I'm just going to label those equations 1 and equation 2, and we will come back to those later. The next bit of information, the other bit of information we've got, is about the second derivative, and we're told that it's this function of t. To differentiate parametrically, or to find the second derivative, we have to find the first derivative, which is dy by dx, and to find that, we work out dy by dt, and we multiply by dt by dx, or divide by dx by dt. So we need to work out these 2 things here. So dy by dt, actually we've already done that. That's the p primed of t here, so 3at squared plus 2bt plus c. And dx by dt, differentiating up here, we get 2 plus 2t. I'm going to factorize the 2 out and write it as 2 times 1 plus t. It's just nice to factorize, but I also notice that 1 plus t features in the final expression for the second derivative, so that might and is likely to become useful. We want, of course, the second derivative. To find a second derivative, well, we need to find the first derivative. I did all that and didn't complete by writing down what the first derivative was. Dy by dx is our expression for dy by dt, and then divided by dx by dt. Now, to find a second derivative, when we have parametric equations, the process is differentiate the first derivative with respect to t, and then multiply again by this dt by dx. Differentiating dy by dx here, that's differentiating this expression, that's a quotient. The expression's a quotient, so we've got to use the quotient rule. So it might help to, or some people like to write down u is our numerator. If we differentiate that, we get 6at plus 2b, and v is our denominator. And if we differentiate that, we just get the 2 out the front. Yeah, it's 2 plus 2t. The constant term vanishes. Differentiation of 2t is 2. So that's what we've got. And so if we work out the second derivative, we are writing down the denominator, the v, multiplying by the derivative of the numerator, subtracting off, writing down the numerator, multiplying by the derivative of the denominator, which was 2, and dividing by, that's right, we can square 2 in our heads, the square of the denominator, and then multiplying by this dt by dx, which is 1 over 2 1 plus t. Now I notice that there's a common factor of 2 in the two terms in the numerator, and there's a factor of 2 in the denominator. There's 1 over here as well, but we can cancel those 2's. Take the factor of 2 out and cancel, and that will make our next line of working just a little bit easier. So we're going to get equal to, I'm going to multiply out this numerator, 1 times 6at, 1 times 2b, t times 6at, t times 2b, minus 3at squared, minus 2bt, minus c, and all of that is over 4, 1 plus t, we've got squared here and another one here, so that's to the power of 3. And then we see that plus 2b minus 2b cancels, and we get a little bit of simplification. We've got a like term, 6at squared minus 3at squared. So that's probably useful for us to do one more line of working before we do something with this. We're going to get 3at squared plus 6at plus 2b minus c, all over 4, 1 plus t cubed. So this is our expression for the second derivative of y with respect to x, and we're told in the question that this is the same as 3 over 4 times 1 plus t. And that looks a little bit nice because we've got some common bits in the denominators over here, so there will be some cancellation. If we solve this, if we just multiply up by this denominator here, put it over here, the 4's will cancel and one of the 1 plus t's will cancel. So we'll end up with this equation here to solve. I guess we need t not equal to -1, because then we'd be dividing by 0 through here, but yeah, we get a problem. We get a problem taking the first derivative if we get t is equal to -1. Let's multiply out the left-hand side. Sorry, the right-hand side. T squared, so 3t squared, 2t times 3 is 6t, and 1 times 3 is 3. And now we can equate coefficients. 3a has to be equal to 3, 6a has to be equal to 6, and 2bc has to be equal to 3. Those first two give us the same value for a, which is reassuring. So 3a equal to 3 means that a has to be equal to 1. Oops, not implies. 6a has to be 6, gives us a is 1, so that's, as I said, reassuring. And the other equation we get is 2b minus c has to be equal to 3. We can't do anything with that immediately. I'm going to call that equation 3. We had equations 1 and 2 above, and I'm going to rewrite them down here for now. 5 over 2, that's equation 1, and 3a plus 2b plus c was equal to 6. That was our equation 2. So now we've got 3 equations, 4 unknowns. We've actually got 4 equations because we know that a equals 1. So that we can get rid of the a's in these last 2 equations and just have 3 equations, 3 unknowns. We should be able to solve those. Here, I notice immediately that if I've got minus c and plus c, if I add equations 3 and 2 together, I'm going to eliminate the c's. So 3 times a, but as we noted a was 1, plus 2b plus 2b minus c plus c, that's 0, is going to be equal to 3 plus 6 is 9. That means 4b has to be 6. That means b has to be 6 divided by 4, which is 3 over 2. Now if we just substitute what we've got into some equations, into equation 3, we've got 2 times 3 over 2 minus c is equal to 3. The 2's would cancel. 3 minus c is equal to 3. That means c has to be 0. And to get d, we've only got equation 1. Equation 1 says a is, which is 1, plus b, which is 3 over 2, plus c, which is 0, plus d has to be 5 over 2. 1.5 and 1 is 2.5 is equal to 2.5. That means that d also is equal to 2. So now we've got an equation p of t, which is a, which was 1, times t cubed, plus b, which was 3 over 2, times t squared, and then a couple of 0 terms after that, which we don't need to write down. And ultimately we're asked to find what the value of this function was when t was equal to 2. So we just simply put 2 in. 2 cubed is 8, 2 squared is 4, divided by 4 is 2, 2 times 3 is 6. So we get a value of 14. And we're done. Let's move on to question B, or part B. Tells us what an odd function is. Basically, it's a rotation about the origin. The function evaluated at negative x is the same as negative of the function evaluated at x. There's a couple of examples, x cubed and sine x. Consider an odd function f that satisfies this additional property. F of 1 minus x is equal to f of 1 plus x for all real numbers. And given that f of 1 equals 2025, find the value of this. This looks formidable because we're having to add up 2025 different terms. So we've got to find a clever way to do that addition for this to work. And we've got this relationship to work with and the fact that it's an odd function. So let's just start with that. I think a good thing to do would be to just look at some values of x. In here, x equal, well, actually just let's look at some values of x. Let's just look at x equals 1. X equals 0 is no good because 1 minus 0 is the same as 1 plus 0. It's just telling us f of 1 is equal to f of 1. So x equals 1 is the first one that's going to give us something of interest. And that says f of 1 minus 1 is, which is f of 0. That's going to be the same as f of 1 plus 1, which is f of 2. So we've found out that f of 0 and f of 0 and f of 2 are the same. We don't know what they are, but they are the same. Let's look at x equals 2. 1 minus 2, which is f of minus 1, is the same as f of 1 plus 2, which is f of 3. F of minus 1, though, because it's an odd function, we can take that minus sign outside. So this is saying the negative of f of 1 is equal to f of 3. So I can see straight away by increasing these, we're always going to get expressions that for values that are 2 apart. Yeah, so if we put x equal to 3 in, you're going to get minus 2 and 4, and the minus 2 will give us something about f of 2. So we're always going to get things that are 2 apart. So let's just have a look at what happens if we wanted to work out in general what f of n is. Then this is the same as f of 1 plus n minus 1. 1 minus 1 is 0, so these are the same things. So that's saying our x value is n minus 1. That's going to be the same as f of 1 minus n minus 1. And that is, of course, the same as 1 minus minus is going to be plus, so it's f of minus n plus 2. And we can take the minus sign out, so that's the same as minus f of, we have to negate all of this, so it becomes n minus 2 inside. So this says a value f of n is the negative of the value that's 2 before. Okay, I noticed something straight away that's interesting about this first one. If we put n equal to 2 into what we've just found here, this is saying that f of 2 is equal to the negative of f of 2 minus 2, which is the negative of f of 0. But this equation is funny because we've got these two things are the same, but they're the negative. The only way the negative and the positive of something can be the same is if this thing is 0. So we've got f of naught is 0. It's not in our equation, but that means f of 2 is 0. And here, every value is the negative of the 1, 2 below. So that will mean f of 4 is 0, f of 6 is 0, and that goes all the way up to f of 2024, which will be 0. So half of our sequence I can add up pretty quickly and get 0. The other half, a value is the negative of the 1, 2 before. So this says f of 1 plus f of 3 plus f of 5 plus f of 7 plus let's go 2021 plus f of 2023 plus f of 2025. This is equal to f of 1. This is the negative of the 1, 2 before, so it's minus f of 1. This is the negative of 2 before, so this is plus f of 1. Negative of 1, 2 before, negative 1. Plus, dot, 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 plus. Now what's this one? Well, these, every second one, so every fourth one is the same, and the fourth ones are always one more than a multiple of 4. This one's a 1 more than the multiple of 4, so this is going to be f of 1. This one's going to be f of 1 as well. That'll be, oh yeah, I've been doing that. F of minus 1, and this one will be f of 1. These all cancel because I did do this different minus f of 1, and then I put the minus inside, but I can just shift that minus outside according to the rules. So we just get f of 1, which we were told in the question was 2025. Isn't that sneaky? They ask you to do a calculation and they tell you the answer in the question. Let's move on to part C. This is similar to part A in some ways. We've got a cubic A, B, C, D are the coefficients, and we need to find something out about that cubic, which is the y-intercept, which is effectively when f of x, when x is 0. So it appears we only need to find D, but probably we are going to have to find A, B, and C on the way. So, and they've got 3 points on the curve, which they tell us the coordinates of, and they say that there's straight lines that go through these and they hit over here somewhere, and wherever these 3 points hit, if we add up the x coordinates, we'll get 25. The sum of the x coordinates is 25. So let's go, and they give us a hint. G of x is equal to f of x minus x squared. Cool. Consider the function g of x equals f of x minus x squared. So let's have a look at that function. G of x equals f of x minus x squared. Now we've got values for f of x at x equals 2, x equals 3, and x equals 4. So let's look at g at those values. So g of 2 is going to be the same as f of 2 minus 2 squared. F of 2 we were told is 4 minus 4, that's 0. Similarly, g of 3 is f of 3 minus 3 squared. F of 3 we were told was 9 minus 9, that's also 0. G of 4 is f of 4 minus 4 squared, which is f of 4 was 16 minus 16, that's 0 as well. So what that tells us is that x minus 2, x minus 3, and x minus 4, these are all roots, not of f, but of g. And if we just look a little bit more closely at g, g is f of x, which we know is this beast. Take away x squared. So we can rewrite that as ax cubed plus the x squared terms we can group together as b minus 1 plus cx plus d. And all that's important for now is to notice that this is a cubic. Cubics have 3 roots. We've found 3 roots. Therefore, g of x can be written in factorized form using these 3 roots. It's not exactly these 3 roots. I left some space. There needs to be a coefficient that you can put in front that will flatten or stretch. But we know the points where it cuts the x-axis. So this is an expression for g of x. And therefore from that we can get an expression for f of x, a different expression, because just by shifting this x squared onto the other side, we see that f of x is g of x, which we just wrote down, plus x squared. Now we want to find these x values out here. So we've got to find the line, and then we have to find the point of intersection. So we find an equation for the line. We set the equation for that line equal to the f function and see where they are simultaneously solved. So let's go about that. I'm going to use 3 colors. black, if you call that a colour. So let's look at AB. The line through AB A and B, we can write that as y minus 4, that goes through the point 2 at 2, 4, is equal to x minus 2 times its gradient. And the gradient is 9 minus 4 over 3 minus 2. So 9 minus 4 is 5 over 1, so it's 5 times x minus 2. I'm going to leave it in this form for now. And then if we look at AC, the line through A and C, we get, it goes through A again, so it's y minus 4. 16 minus 4 over 4 minus 2 is the gradient, x minus 2. So that's 12 over 2, that's 6, x minus 2. So we've got an equation there. And BC, so the line through B and C, that's y minus 9, 3, 9 is the point we're going to be using. 16 minus 9 over 4 minus 3, x minus 3, that's just 7, x minus 3. So we've got these 3 equations of lines that intersect again with our curve up here. To find the intersection, we just want, if we substitute in, so effectively f of x is y on the cubic. So if we substitute this in to each of these equations for y and solve those, we will find out the points of intersection. So let's have a look at that. So we've got y, f of x was a, x minus 2, x minus 3, x minus 4, plus x squared. And then up here we take off 4. So this is y minus 4. And that's going to be equal to 5 times x minus 4. So was it 4? X minus 2. I didn't think 4 was right. And what I see here is that x squared minus 4 can be factorized as x minus 2, x plus 2. And then I see that each of these terms has got a common factor of x minus 2. So we can write this, that's x minus 2, common factor, times, big bracket, a times x minus 3 times x minus 4, and then plus, taking the x minus 2 factor out, it's going to be x plus 2, and then equal to, we could put 5 over here, but we can subtract the 5 and make that equal to 0. And now this is x minus 3, so I can factorize now an x minus 3 out. So we get x minus 2, x minus 3, a, x minus 4, plus 1 equal to 0. So this is 0, this is 0, or this is 0. This is the 2 points x equals 2 and x equals 3. We're not interested in those. We're interested in the other point of intersection. So that means we want, this implies that x equals, shift the 1 on the other side, divide by the a, add the 4. So that's one of our x coordinates for a point of intersection. The next one, same thing, it's y, which for the cubic, y is this thing here. Take away 4 has to be equal to 6 times x minus 2. Now again, this is the same factorization, x minus 2, x plus 2. So we've got a common factor. We take that common factor out, x minus 2 times a times x minus 3, x minus 4. We're going to get plus x plus 2 here. Take off the 6, shifting that to the other side, is equal to 0. This is x minus 4, which gives us another common factor. So we get x minus 2, x minus 4, bracket a, x minus 3, plus 1 equals 0. And again, these two are the 2 and 4, the coordinates of points A and C, x coordinates of points A and C. So what we're interested in is x equal to minus 1 again, divide by a again, add 3 this time. And finally, a, x minus 2, x minus 3, x minus 4, plus x squared. That's the y value for the point on the cubic. Take away, I think this was 9. Yeah, take away 9 equals 7x minus 3. This time, x minus 9 is x minus 3 times x plus 3, common factor. This time x minus 3, so we take that out. X minus 3 times a, x minus 2, x minus 4, plus x plus 3, and then take away 7 equals 0. This is x minus 4, so we can take that common factor out. So we got x minus 3, x minus 4, a times x minus 2 plus 1 equal to 0. So that this is the one we're interested in. 3 and 4 are points B and C, the x coordinates are point B and C. So we get x is equal to minus 1 over a plus 2. And golly gosh, we ran out of room. Let's go up and do some on the side here. So we've got these 3 values, minus 1 over a plus 4, plus minus 1 over a plus 3, plus minus 1 over a plus 2. And the question told us that those values add up to 25. These are common, so there's minus 3 over a plus 4 and 3 is 9, and 4 and 3 is 7, and 2 is 9. So minus 3 over a equals 16. A equals minus 3 over 16. So that tells us our f of x, it's minus 3 over 16, x minus 2, x minus 3, x minus 4, plus x squared. And we want to find out the value when x is equal to 0. So it's minus 3 over 16 times minus 2 times minus 3 times minus 4 plus 0 squared. 4 times 2 is 8, goes into 16 twice, so we get 3 times 3 is 9 over 2 minus, 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 minus. There's 4 of those, so it's plus, and so that's our y-intercept. Okay, so any questions, let me know in the comments. Otherwise, I'll see you next time and we'll have a look at question 3. Thank you very much.